Hi, my name is Alvi. I'm going to give a presentation on my DSA5303 project from the University of Oklahoma, spring 2018. And my project is portfolio management using machine learning models. And here's my presentation outline. And first of all, let me talk about where I get my project idea from. At the beginning of this class, and we talk about that the investor they like expected return, they dislike risk. But is it possible that we can get higher expected return and higher than the market line you see here? The short answer is if we can predict the price of the stock in the future, certainly we can get higher expected return. That is what this project is trying to answer. And can we use machine learning model to get higher expected return? And let me give a quick overview of my portfolio management application. And it's implemented using Python. The two main libraries I use is Panda and sklearn libraries. And my application use S&P 500 company stocks only. That means what? And from my application perspective, the entire stock market only consists of the S&P 500 company. Since everything I buy and sell is from S&P 500 list, and it's fair to say that SPY, which is the index fund for S&P 500, is my tangency portfolio. It's a tangency portfolio. And let me quickly describe how the application works. And first of all, I will initialize the portfolio. The portfolio will have a 25 stock maximum. And I have a $500,000 of capital available for trading initially. So for each stock in the S&P 500 list, I will calculate the expected return and the CAPM value using the historical data. I will use the ratio of those two values to determine which stock I should be included in my portfolio initially. So by doing that, I will have a portfolio that has a very low beta, which is the risk, and a reasonable expected return. And for each trading day, I will apply the data model or a trading strategy to each stock in my portfolio. So what the data model is going to do is it will try to predict what is the price of that stock in the future. If the stock is predicted to go up in the future, of course, I will keep the stock in my portfolio. Otherwise, I will sell that stock. If it's predicted to go down, I will sell the stock, and then I will use the fund from selling the stock to purchase another stock from the market. And which stock I'm going to purchase from the market, and I will apply the same data model to that stock. If that stock is predicted to go up in the future, I will include that in my portfolio. And I want to mention that since this is just a simulation, there's no trading fee, and the stock price does not fluctuate throughout the day. It's constant. In fact, I'm using the closing price of the stock in my simulation. And here, I want to talk about the data preparation step. And first of all, I use Pandas data reader API and to write the stock data to CSV file. And the reason is that so that I can retrieve the data from my local hard drive instead of going to the web every time I run my simulations. And apparently there's some data cleansing that I have to do, and mainly to remove to handle the missing value of the data set. And here I implemented the data model and trading strategy, and I implemented a moving average trading strategy. It signals a buy when the 42-day average is above the 252-day average, and it will trigger a sell signal when 42-day average is below 252-day average. So I will use those two pieces of information to determine whether I will buy or sell a stock from my portfolio. The data model I implemented are linear regression model and SVR model with three different kernel. Linear regression, and it is a supervised data model, and it will use the historical stock data as training data and to fit a linear equation of the form and y equal to ax plus b. And I don't have to implement the model, and Python's sklearn package has the linear model API. So the key to build a functional linear regression model is to determine how many data points we should be include in the regression model. And apparently, if you include 20 days of data versus 1 year of data, will give you a completely different linear equation. So for my application, I use 42 days of data point to build the linear regression model. And the SVR model is based on SVM, support vector machine, and is a supervised learning model as well. And we study SVM in our courses. So it separates the data into classes. And so we can also use SVM for regression and also use that to predict the stock price. Basically, how it works is that you use the space between the data point as a margin of error to predict the most likely next point in the data set. And the sklearn package provides the API to SVR as well. So like linear regression, we have to determine how many data points we should be included in the SVR models. In addition, SVR models also have a few tuning parameters, and one of the most important tuning parameter is the kernels. So RBF kernel is based on the Gaussian distance between the points, and linear kernel, it works well if the data is linear separable, and polynomial kernel, and it would allow the learning of nonlinear models. And here's the model statistics and for AAPL Apple stock. The standard deviations you see here is the standard deviation between the predicted price and the actual price of the stock. And then linear regression appear to have the lowest standard deviations. Accuracy is whether measured by whether we predicted the up and down trend of the stock correctly or not. And here you see that there's is a plot of the SVR polynomial model. The red line here is the actual data, actual price of the stocks, and the blue line is the fitting of the stocks. And as you can see here, and actually it fit pretty well in the model. So the accuracy is 78%. Here is the plot for linear regression models, and as you can see here, it doesn't fit that well. and the accuracy is only 56%. Next, we're going to do the simulation. So I will run the back testing simulation from January 1st, 2013 to April 1st, 2018. So, and here's the result I get from the moving average strategy. Apparently, and at some point, um, the moving average strategy is performed better than the market, which is the SPY index. But at the end, they turn out to be the same. And here's the result from SVR RBS kernel. So as you can see, and it outperformed the market index, which is SPY index, from the beginning all the way to the end. At the end, and the return is about 100%. And this is the return for the other model. So as you can see, SVR has the highest return, and followed by the polynomial kernel SVR model, and linear SVR model, and linear regression, and finally, moving average and SPY has about the same return. To do a demo and to show how the application works. Okay, what you see here is my project repository here. And so first of all, before I run the simulation, I have to set the simulation end date to a shorter date. Otherwise, it could take some time for the simulation to complete. So I say to 1 year from, January 1st, 2015, which is 1 year of simulation. So I will start the simulation now. All right. So while the simulation is running, I want to talk about just the structure of my project. So here you see that the utility.py file, and it contains mainly the data processing functions. So I use that to create, to download the stock data from the web to my local hard drive. So the CSV file you see here are mainly generated by the utility function. And the npd.py, which is my implementation of a portfolio and a stocks, and basically how I represent a stock and a portfolio in my application. And also that you see here, there's those linear regression model, moving average model, and SVR models. So all those models, they implement a method called get trade action. Basically, you will give it a day, right, and a stock. So it will tell you, use the model to tell you what is the recommended action on this trading day. Should you hold the stock? Should you buy? And should you sell it? And basically all the model like implement this common method, these common functions. So you see that see the simulation is still going, and there's a lot of trading, happening. So throughout the day, if I had to pay transaction fee, that's probably going to cost me a lot. So that's why this is only a simulation. It's not meant to be used for real trading. Okay, it's almost there. So it's October, and just give you a few more seconds. It should complete. Okay, sorry about the wait, and finally is completed. And so this is, yeah, I think you see this plug, in the previous slide, but basically the only difference is this is from January 2014 to January 2015, and this is the portfolio return by using SVR RBF kernel. Okay, so let's go back to our presentation here. So in conclusion, can we predict stock market using data models? Well, this is not an easy question to answer. So I would say that to some extent, yes. But is it a reliable method? And probably not, right? So you will have to, if the data model still is a it's a data driven model. So it will ignore all the non-systematic risk, which is like for a stock to go up and down. Is a lot of the time it depends on the earning of the company. So I would say that it's going to be very difficult for a data model to able to predict the earning of the company. So by the way, and all the simulation I did is purely data driven. So here that you see that, oh yeah, this one it give you a very high return, but the one of the main reason is that in the last few years, and the SP, especially the stock in the S&P 500, list, they perform relatively well, overall. So that's why if you purchase a few stock in the list and hold it for a few years, and you really likely to have a high return as well. So, and okay, lastly, I just want to just mention that I put my project, all the source code and data file in my GitHub repos. So you can go in here if you're interested, see what I'm doing. So basically, what I recommend is that if you go in there, you need to install the sklearn package and the panda package, and also the matplotlib library, which is used to plug the whatever you see in my slide. So with those three library, and you should be, if you go into the market simulator and just execute this program, you should be able to, if you clone the repository correctly, you should be able to at least run the simulation on your own. So okay, and at the end, yeah, thank you guys, thank you everyone. I hope you find this project interesting and have a great summer. Thanks.